Hello everyone. In this video, I'm going to present a project I did for my Voice over IP and Multimedia Networks class. It was on implementing a Voice over Wireless Ad Hoc Network, a hands-on SIP or SIP-based experiment. So here's what we're going to do today. First, I'm going to introduce the concept of Session Initiation Protocol or SIP. Then I'm going to talk about the lab tools I used, and then the goals of the project, followed by the project tasks that were accomplished. And then I will talk about the results and analysis, followed by the challenges I have faced, and then the summary. So let's start by talking about VoIP or Voice over Internet Protocol. As you know, it is a technology that aids in conveying voice communication and multimedia sessions over IP network. A Session Initiation Protocol or SIP is one of the most common protocols used in VoIP technology. It is a signaling protocol used to create, modify, and terminate a multimedia session over IP. A session is nothing but a simple call between two endpoints, and an endpoint can be a smartphone, a laptop, or any device that can receive and send multimedia content over the internet. So basically, SIP is an application layer protocol. It is designed to be independent of the underlying transport protocol. So SIP applications can run on TCP, UDP, or any other lower layer networking protocols. And typically, SIP protocol is used for internet telephony and multimedia distribution between two or more endpoints. For example, one person can initiate a phone call to another person using SIP, or someone may create a conference call. And other SIP applications include file transfer, video conferencing, etc. So now let's briefly talk about the procedure of SIP. Before establishing a call, SIP follows a three-way handshake, and messages exchanged in a SIP handshake are shown here. Caller initiates a call by sending an invite packet, and then callee or the receiver sends a 200 OK to accept the call, and then caller then sends the ACK indicating the completion of the handshake. And SIP follows a server-client architecture where client communicate through a proxy server, which is also called a SIP server. And the topology shown in the diagram is known as a SIP trapezoid. And here's the process in brief. When a caller initiates a call, an invite message is sent to the proxy server 1. This server attempts to resolve the address of the receiver with the help of a DNS server and finds proxy 2. Proxy 1 forwards the invite request to proxy 2, and then which is the inbound proxy server for the receiver here. Proxy 2 contacts the location server to get information about the receiver's address, and then it forwards the call to the destination. And once the user agents get to know their address, they can bypass the call and conversations can pass directly. So here's the basic flow of the message exchange during the SIP session. So an invite request is sent to the proxy server, which initiates the session, and then the proxy server sends a 100 trying response immediately to the caller, which is Alice here, to stop the retransmission of invite requests. And then the proxy server searches the address of Bob or the receiver here in the location server, and after getting the address, it forwards the invite requests further. And after that, a 180 ringing, which is a provisional response, is generated by Bob and returned to Alice. And then a 200 OK response is generated soon after Bob picks up the phone. And then Bob receives an ACK from Alice once it gets 200 OK. After that, the session gets established, and RTP packets, or conversations in this case, start flowing from both sides. And after the conversation, any participant, Alice or Bob, can send a BY request to terminate the session. For example, here, BY reaches directly from Alice to Bob, bypassing the proxy server. And finally, Bob sends 200 OK response to confirm the BY, and the session is terminated. So moving on to the experiment that I have done. So here are the lab tools I have used. I used 4 machines in total. Asterisk is an open source software which functions as IP-PBX framework that helps in exchange server and VoIP messages. The server is deployed on a Linux machine using Asterisk software. And then ad hoc network is used to collaborate with the VoIP clients in a small decentralized system. And once the clients are registered through the ad hoc network, X-Lite is used as a soft phone to establish VoIP calls. And in addition, Wireshark was used to capture packets and analyze them. So here are the project steps. First, I set up the SIP proxy server. That was a machine with Linux installed in it. And then I have set up the ad hoc network, which had its several steps as well. And then the next step was to configure Asterisk files for SIP protocol, which I will be talking in detail later. And then add clients here. Here are the 3 clients that I've added. And I've manually added the IP addresses for them as well. And then finally, I implemented 4 tasks, which I will be talking next, and analyze IP packets from Wireshark. So here are the 4 tasks that I have accomplished successfully in this experiment. The first 2 tasks were between 2 clients, and then the rest were between 3 clients, as we will see later. So the first task was to establish a call between 2 clients via the proxy server. There are 2 important files in Asterisk that we need to modify to accomplish this. The first one is the sip.conf file, where first you have to tell it to use the SIP protocol. So 5060 is a port that SIP uses. So here's how you manually modify this. And then here's how you add the clients in your sip.conf file. As you recall, these 2 are our first 2 clients, 2000 and 2010. And then the next part, you have to modify the extensions.conf file, where you basically tell Asterisk software what to do with your clients. So you can set here the hold times and things like that. So here's a screenshot of where it shows that caller 2010 is successfully calling the client 2000. And this is a screenshot of captured logs using Wireshark, where client 2 is calling client 1. And here are the messages exchanged between them. So the invite message, as you can see here, is sent to client 1, and the server responds with the message trying. And then OK response message was sent to the SIP server, and the ACK response is sent to client 1. And finally, the message bye sent from client 1 to the server, and OK to send from the server to the client. Wireshark can also analyze each message packet and give us details if we want them. For example, this screenshot shows the captured message for captured SIP message OK, where you can look up information like the response time of 147 milliseconds here, or the status code, which is 200 for OK, and things like that. And Wireshark can also create flow graphs for a connection. Here it shows the flow graph for the connection established and termination between the SIP server and the clients. And these are pretty similar. This whole process is pretty similar to the ones that I have explained before. So in this part of the experiment, or the second task, we make one user busy while the other user tries to call it through the server, and we want to analyze the SIP messages exchanged. We can use this application in case of timeouts or invalid conditions if we want. So while user 2000 calls 2010, initially executed application will answer. Then the caller will hear a play tone for a busy condition. This is achieved due to the busy extension right here that you have to add to the extensions.conf file. And here's the screenshot of the captured logs where we can see that the invite message is sent, and then the response is the 41 unauthorized, which is due to the busy condition we added here. And then everything else is pretty much similar to the process before. So the third task, we add another client with number 2020 right here in the sip.conf file. And in this scenario, client 3 tries to call client 1, but the call between client 1 and 2 is already established. So when the third client tries to call the first client, it keeps the second client on hold and accepts the call from the third client. And after completing the call with the third client, it resumes the call with the second client, which you can clearly see here that the second client is on hold while the client 3 and client 1 are talking. So I'm not going to go into detail of the Wireshark captures here. I'm going to move on to the next task, which is called conferencing. Client 1 and Client 2 were already in call, and Client 3 tries to call Client 1. And then Client 2 puts it on hold, and finally, again, after the call is established, they invite the third caller, and then they are in a conference like that, as you can see here. It was accomplished successfully. And there are very similar, this Wireshark capture is very similar to before, and I just want to show you the highlighted part where we can see that the SIP messages bye and OK were seen twice, which indicates that the termination of the conference call between 3 users were accomplished successfully. So I faced several challenges during this experiment, and here are the top 2. The first one was installing Asterisk. Since the latest version of Ubuntu was used, the traditional installation process did not work. So to install Asterisk, it was downloaded from GitHub and modified accordingly. And here's an overview of the commands used to install Asterisk if you want to check them out or need them someday. And then the second challenge was to connect the clients to the ad hoc network, because Windows 10 does not have the ability to directly connect to the ad hoc network using Wi-Fi connections, and as all of the client laptops had Windows 10, the proper ways to connect to the ad hoc network had to be figured out. And the steps included manually adding the ad hoc network to the list of connections, and then using these following commands. I have provided them here as well if you want to take a look or need them someday as well. So furthermore, for some unknown reason, after connecting to the ad hoc network, the client computers kept crashing several times. The whole process of the connection had to be repeated several times to establish the calls, but eventually I overcame this challenge as well. So to sum up, in this project, a VoIP environment was created using SIP to study exchange of messages during various phases of calling. For each case, the SIP messages were captured, analyzed, and documented using Wireshark, and overall this project was very helpful to implement the concept of VoIP in a real-life communication system. Furthermore, all the obstacles faced during this experiment proved to be very useful for me to get a deeper understanding of the concepts of today's networking world. So I had a lot of fun sharing this concept with you, and thank you so much for your time.